This lesson covers how to solve a quadratic equation by using the quadratic formula. The quadratic formula is x equals minus b plus or minus the square root of b squared minus 4ac all over 2a. And the quadratic formula can be used to solve any quadratic equation. It doesn't matter if it's factorable or not. And here are the steps for solving with quadratic formula. The first step is to write your equation in standard form. You want to make sure you write in the form of ax squared plus bx plus c equals 0. Then you're going to identify your a, your b, and your c. Remember, a is the coefficient of x squared, b is the coefficient of x, and c is your constant. Then you're going to write your quadratic formula. Write the general form so you can get focused on the problem. Then you're going to substitute in your values for a, b, and c. Then you're going to simplify, follow the order of operations, and you'll have your solution for x. Let's look at a couple of examples. Here I've got 3x squared minus 5x minus 2. First, I look to see if it's in standard form, and it is. It's equal to 0. Then I identify my a, my b, and my c. A is the coefficient of x squared, so it's 3. B is the coefficient of x, so it's minus 5. C is the constant, so it's minus 2. Remember to make sure you pick up the signs in front of your coefficients, or for a, b, and c. Then I'm going to write the formula. X equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. And it's a good idea to go ahead and write this general form every time that you work these problems. That way you can get focused on the problem and stay focused on what you're doing. After I do that, I'm going to make my substitutions. So my b is a negative 5, so I have a minus 5 plus or minus the square root of a minus 5 squared minus 4 times a, which is 3, and then times a negative 2 for c, all over 2 times 3. Then I'm going to simplify. A minus 5 will be a plus 5, plus or minus. The negative 5 squared will be 25. A negative 4 times 3 is negative 12. A negative 12 times a negative 2 is a positive 24, all over 6. Then I can combine what's under the radical. The 25 plus the 24 is going to be 49. So I have 5 plus or minus the square root of 49 over 6. Then I'm going to see if I can simplify the radical. If I can simplify the radical, I do, and in this case I can. So I've got the square root of 49 becomes a 7. So now I have 5 plus or minus 7 over 6. Since I don't have a radical right here, I can add my numerator across my numerator. So I'm going to do 5 plus 6 over 7, 5 plus 7 over 6 as one solution, and the other solution will be 5 minus 7 over 6. So 5 plus 7 is 12 over 6, which would be 12 sixths, or 2. And then 5 minus 7 is a minus 2 over 6. So a minus 2 over 6 reduces to a minus 1/3. Okay, so let's look at one more example. Suppose I have a problem like this. I've got 2x squared equals a minus 6x minus 7. Originally, it's not in standard form, so I'll go ahead and rearrange it. I'm going to add 6x to both sides and then a 7 to both sides to get it in standard form. Once I have it in standard form, I'm going to identify the a, the b, and the c. A is 2, b is 6, and c is 7. Then I'm going to write my general form. X equals a minus b plus or minus the square root of b squared minus 4ac all over 2a. Then I'm going to plug my values in. I have a minus 6 plus or minus the square root of 6 squared minus 4 times 2 times 7 all over 2 times 2. Then I clean my problem up. That minus 6 becomes a minus 6 plus or minus 6 squared is 36. A minus 4 times 2 is a minus 8. A minus 8 times 7 is a minus 56 all over 4. Then I'm going to simplify the radicand. I've got 36 minus 56, which will end up being a minus 20. Now in this example, I have to take the square root of a negative number, and at this point you do know how to do that. And we're going to accomplish this by thinking about negative 20 being broken down into the factors of negative 1 times 4 times 5. I'm going to factor out the negative 1. I know the square root of negative 1 is I, so I'm going to be able to pull that out of the radical. I know the square root of 4 is 2, so I know that's going to leave the radical. So what happens is I end up with 2i coming out of the radical. So I have a minus 6 plus or minus 2i square root of 5 over 4. Now before you say you're completely finished with a problem, pay attention to your answer. Look at those numbers outside the radical. I'm going to look at the negative 6, the 2, and the 4. If there's something that I could divide evenly through all three of these numbers, then I will go ahead and do so and reduce my fraction. Remember, we only look at the numbers outside of radicals. So in this case, the 6, the 2, and the 4, I know I can divide through by 2. And negative 6 divided by 2 is negative 3. 2 divided by 2 is 1, which leaves behind an I, square root of 5. 4 divided by 2 is 2. So my answer ends up being negative 3 plus or minus I, square root of 5 over 2. So this is how you solve by using the quadratic formula. Remember, even though the formula looks a little daunting, it's not that hard to memorize. Make sure you get it memorized. And go back over these slides if you have questions, and come to class next week and let me know if you have any questions.